All right, so let's get going on today's class. So today we're going to talk a little bit more about research methodology, one last little thing that you need to consider. But before we get to that, once again, kind of keeping our long-term goals in our minds. The Undergraduate Research Conference has now confirmed their date, so it was probably going to be Friday, April 12th. Now it is definitely Friday, April 12th. So this is the new website for the South Bend Undergraduate Research Conference. And the application submission deadline is Friday, March 22nd. So by that day, and we'll work our way towards that. Basically what you need is an abstract that is a summary of your work, whether it's completed or still a work in process. It's basically just a summary for submission. So keep that in mind, and you can be part of IUSB's mission to foster an experiential learning environment that engages students in the joy of researching and expanding the knowledge base of their academic area. So once again, this is our commitment to giving back, to becoming producers of knowledge in psychology. All right, so once again, this is our roadmap for what we're trying to accomplish this semester. What we're going to be working on today is right here. So the topic paragraph and research hypotheses, I have those now. So this will also be a little bit for the introduction draft, but mostly we're going to wrap up our look at some of the things that you need to consider as you put your experimental design together so that you can write your method section draft. All right, so the thing that we're going to focus on today is going to have to do with research and validity for the method section. But before we get to that, I'm going to talk about an upcoming class, the IRB Protocol how-to classes that we have coming up. And then we're going to talk a little bit about the introduction draft and the peer review assignments that are coming up as well. And then we'll talk about validity, some things to consider as you're putting together your method section, and the reliability, some things to think about. Well, not as you're putting together your method section, but as you're designing your experiment. So some students have come to me with concerns about the validity of their measures, and we'll see what we can think about, or what we need to think about in that terms, and what can be done for that. And then lastly, we'll end it with some group time, some collaboration, so that you can work with each other to hammer out some of these details, help each other, and also call me over if you have any questions. All right, so in terms of the IRB protocols, Erica Zinda, our IRB liaison, will be visiting us in class on Thursday, January 24th. So she will be here to answer all of your IRB questions. And we have been in discussion specifically, I've been in discussion with Erica in terms of the need for IRB, for actual IRB protocols, for the projects that are being done in this advanced lab. And in our discussions, it has been brought to my attention, there are sort of like new criteria since the last time that I've done this that determines whether or not IRB approval is necessary. And I am pleased to announce, mostly because it's going to probably make most of you pleased, that the full IRB procedure is not going to be necessary for most of the projects in this class. So I will read through your introduction and topic paragraph, your topic paragraph and research hypothesis. I'll read through those and kind of make the final determination. But as it kind of stands right now, and as we're kind of seeing, except for two special cases who have already submitted to the IRB, it really doesn't look like even those doing experiments are going to have to go the full IRB procedure. That being said, we are still going to do an IRB assignment. We're still going to have that experience of what it would involve if you were to go through the IRB process, because that is an important aspect of not only making sure that our experiments are sound, but that we have all the details worked out, that we're doing things ethically. So we can't do whatever we want to do. There's still that process, but it's going to be what Erica likes to call an IRB light procedure. And the turnaround on that will be a lot quicker, I imagine, than going through the actual IRB procedure. So that's all going to be spelled out in more detail. I thought everybody who's doing experiments would have to go through an actual IRB protocol. As it looks more and more, as I get more and more clarification, it looks like unless you're dealing with a specialized population, like two of our researchers are, you won't actually have to go through the full IRB procedure. And of course, if you're doing a corpus analysis, you were never up really for the IRB procedure. But on that note, everybody will be doing the IRB light unless you've already submitted your protocols. All right, so that's all coming up on January 24th, so a week from today. So what we're going to do before we get into reliability and validity, that's actually out of order. Let's talk about the final ideas about the introduction draft and peer reviews. So some additional details to think about as you're going through your drafts. So in your drafts, we are eventually going to try to publish these. I've founded a journal, it's a Journal of Cognition and Diversity. So it's one of the places where we can publish these journals. But one of the things that really helps your story come across is the use of images. So we're writing our first section here, the introduction draft, but this applies to every section that you use. Feel free to use images in your drafts. You can use the images, you can use figures, figure number 1, figure number 2, whatever you think is going to make it the best story for your draft, the most understandable story. So they say a picture is worth 1,000 words. If you can use a picture to help clarify information, do that for your reader. I find it is very telling for the power of images that children's stories, who are for an audience that struggles with following the information that is being presented, are chock full of images and pictures to help them make sense of the story. I find it a little bit weird that we deny that for ourselves as adults, right? So if you have a picture that you want to use in your paper, feel free to use that picture. There are, however, some stipulations. First stipulation is, because we are thinking about possibly publishing this material, you want to make sure that you have the rights for your pictures. So many pictures are copyright. Not all of them, many of them are. And it's oftentimes difficult to know exactly which one is which, and if it is copywritten, who owns the copyright. So for these assignments, for these drafts, if you do want to use an image, one stipulation is that the images must come from Wikimedia Commons. So Wikimedia Commons is a resource that you can find a lot of scientific images. You can find a lot of images that would help your research report. So for example, if you need an image of the hippocampus, you can find this in Wikimedia Commons. If you need an image of color space, you can find this in Wikimedia Commons. If you need an image of color space in terms of activation of your different channels, you can find this in Wikimedia Commons. And the attribution license for the images that you find the licenses for use are typically very clear. So typically when you click on an image, you just scroll down the page and it will say what it's used, how to use its licenses. And 99 times out of 100, the only thing that you need to do in order to use this image is attribution, which means that you just cite whoever you got the image from. So whoever was the artist, and their name will be there, you just need to cite them in terms of using their image. So if you want to use images in your reports, starting with your introduction if that's what you want, but this applies for everything, you can find those images at Wikimedia Commons. It needs to be, though, something that is attributable. So you cannot just grab images off of Google and just cite the web page that you took them from, because those images might be copyright, which means that if anybody reads your article and recognizes those images, we're going to get a cease and desist letter and possibly even worse. So make sure that you're using images that you do have the rights to do. And again, in Wikimedia Commons, the rights are there as long as you attribute ownership of that image. The other thing that you can use, or the other source of images that you can use, is you can use any images that you own the copyright to, and those are any images that you create. So when you create graphs of your results, when you create images of your stimuli, right? So if you are creating stimuli and then you take scans of those to use in your paper, those are your images, you have created those. You own the copyright to the images that you've created, so you have permission to use them. So if you have any original images, feel free to use those as well. And then those ones do not need to be referenced because you own the copyright to those. All right, so additional details. The introduction draft is actually going to be submitted to Canvas. So I think I originally mentioned it's going to be turned in. We're going to do the drafts in Canvas. I wanted to kind of keep it all in one area, you know, just one place that you need to go to in order to see your assignments and see your drafts. So it's going to be submitted to Canvas, and the peer reviews are also going to be done in Canvas. So there's a way to do peer reviews in Canvas. If you're familiar with that, awesome. If not, we'll show you a little bit about that. But for additional information, you can check out the file in the Canvas files in the folder named Peer Review Information. There is a few PDFs that'll guide you along. Number one, how do you know if you have a peer review assignment to complete? How do you submit that peer review for an assignment? And then also, this is optional, but there's CrocDoc in Canvas assignments, and that's a way to make comments and notes directly onto the document that you're reviewing. But that's additional, but if that's more your style, feel free to check that out and to use CrocDoc. So before we get into the validity, the last thing that I will mention is that the assignments are up right now, and you might, well, it would be a good idea to take a look at the reviews of these assignments, the peer reviews that are required, and then that might help you, you know, sort of develop your introduction draft and some of your other drafts. So the introduction draft, place where you can submit it, that's already open. And if you go there, you can see the peer review criteria. There they go right there. All right, so because this is not your first research paper that you're writing, and hopefully it's not the first time that you've been asked to review, these will be open-ended questions. So this was taken straight from a professional journal's peer review guidelines. So what you're going to be doing is you're going to be reading your peer's introduction section. There's going to be 3 sections that you're going to read, 3 submissions. And you want to ask yourself, does the submission analyze the subject to an adequate depth? Is the text rigorous enough? If not, where could it be developed? So have they given you enough information? Or is there things lacking? Are there holes in your understanding? So did they, you know, are you still confused because they didn't provide enough information? If they haven't, where should they provide a little bit more? Does the submission offer a balanced critical view, avoiding biased or highly subjective opinions? So does it kind of take into account all different areas of, you know, the science, or does it only concentrate on what it wants to promote? Does the submission show an awareness of previous existing scholarship on the subject? Are all facts, particularly disputable information, verified and referenced? If not, please explain what areas could be developed. Citations for references should be in APA format. So you will need citations for your introduction. So make sure that you're citing where your information comes from. And then when you're reviewing somebody else's introduction, sometimes I find that writers, students tend to miss citations that they should have. So if they do, make sure that you call them out on that. Make sure that you say, well, this fact here should have a citation. It's not your own opinion. It's, you know, a statement of something. It's not common knowledge, so it should have a citation there. Is the submission free of typos and obvious spelling, syntax, and grammatical mistakes? Is the English at a good enough quality for publication? So let them know about that. And then this one is for images. Does the submission specifically refer to the images included? So if you have a picture in your introduction draft, at some point in your draft, you should say, see figure 1. So the pictures aren't for decoration, they're for communication purposes. So make sure that they refer to the images and are all images from third parties correctly attributed to the original source. So if you take an image, did you attribute it to Wiki Commons? Let them know about that as well. And then finally, please give a summary of the submission, including any information you feel is relevant that has not been included elsewhere. So if at the end of all that, there is still things that you feel that you need to say or let the reader know about to improve their manuscript, please let them know. So you will be assigning points on a 5-point scale, and you will also be making written comments. So each criteria requires a written comment as well as your indication of how well they did on a 5-point scale. And as I've done in other classes where I've used peer reviews, this is going to be anonymous. You're not going to know, nobody's going to know who reviewed their assignments. You will probably know whose assignments you're reviewing. This is because you'll become more familiar with everybody's project in here. But one thing I want to let you know is that the peer reviews are by far the biggest factor in improving the quality of the final research paper. So because of that, honest feedback is everything for a peer review. So in order to sort of promote this, I just want everybody to be assured that I do not take a look at the peer reviews before I assign a grade for the draft. And I also grade the drafts on a very slippery slope of, you know, this is a draft. It's not being graded with the same criteria that your final papers will be graded. What I'm looking for in a draft is that it is a good first draft. Not that it's a final finished product, but is it a good first draft? So if you need to be brutal in order to help, you know, your colleagues improve their writing, then this is the place to do it, right? If the submission is just filled with typos, you know, let them know. Let them know that they need to go through and try that again. If they don't have a lot of references to previous series, let them know that you need to find a little bit more evidence. You need to cite some of these things here, because again, this is going to be the biggest aspect of improving their final product. And also, when you're writing your own introduction section and finalizing your own introduction draft, ask yourself these questions, right? Try to step back from it for a moment and say, all right, do I have adequate depth? Have I explained enough of the topics that I'm talking about? Am I being biased, or have I used a highly subjective opinion type of writing? Do I have citations in APA format? Oh, no, I don't. Maybe I should add in some of those. So you can kind of use this as a checklist, because that is also what you're going to be reviewed on in your introduction. All right, any questions on the intro? All right. So those peer reviews will be made available basically as soon as the deadline for the introduction passes. So until that time, you know, just use that as a guideline for your reviews. Okay, so let's get to the methodology portion of today's class, and then we'll split up into groups so you guys can help each other out and work on some of these details. So I've had some discussions with students about some of the measures that they're going to be using. So hopefully at this point you've thought about not only what it is that you're going to be measuring as your independent variable, your dependent measure, but also how you're going to be measuring it. What are the operational definitions for how you will be measuring those? What are the tools you're going to use? So one of the things that pops up, especially if you cannot find an established measure for what it is that you're doing, or if you're doing a corpus analysis and you need to find some sort of criteria for inclusion or exclusion of, you know, certain stimuli, then it's a good idea to start talking about the validity of measures. So validity basically has to do with whether or not your measure is actually measuring what it is that you say it's measuring. Right? So if I have a math test and I'm trying to measure mathematical ability, my math test has construct validity. It's actually measuring math ability. But if I have a tape measure and I say, that's how I measure math ability. I measure people, and this person is 5'1" math ability. This person is 6'2" math ability. That has no construct validity, right? We're not at all measuring what we say we're measuring. So you want to make sure that your operational definition, as much as possible, reflects what you truly are trying to measure, that theoretical meaning of the variable. So whether or not your measure is actually measuring the concept is what a lot of you are wondering about these days. And there's no way of knowing construct validity directly, right? It's very difficult to get to this directly. So what they have is they have indicators of construct validity. They have things that kind of show you that you are getting close to construct validity. So if you can find these indicators, especially in other, for other measures, feel free to use those. So indicators of construct validity. First one, and this is the easiest one, this is one that you yourself can assess, is space validity. And this is a question of whether the measure appears to be measuring the concept. So when I said math test, if you open up a test and it's got a whole bunch of numbers and addition signs and equal signs, that looks like a math test. That has space validity. If, on the other hand, you open up that math test and the first question is pick your favorite color, the second question is if you were a hamburger, what type of hamburger would you be? That has very little face validity, right? So face validity is whether or not the measure appears to reflect the construct being measured. Content validity is whether or not it is linked to the universe of content that describes the construct. So this is going to be helpful when you're putting together, if you need to put together one of your own measures, what you should do is you should start thinking about or finding evidence of what are other things that go with that particular construct, right? So for example, if you are measuring levels of abuse, right, for example, what you should do is you should go into the universe of content for abuse and see what they say constitutes abuse. So you can say, oh, well, the universe of content says that there's physical abuse and that there's emotional abuse. And they also note financial abuse. And they also note this other kind of abuse. So that is an indication that those are the type of things that you might want to include in your measure when you're measuring the amount of abuse. So make sure that it's linked to that universe of content. Predictive validity, not going to be very helpful if you're making your own measures or your own criteria. But if you are looking for different measures that already exist, one thing to look for is their predictive validity. Are they able to predict behavior on our criterion mentioned in the future? So things like the SATs have predictive validity for how you're going to do in university. Things like GREs have predictive validity in terms of how you're going to do in grad school. So that's going to be not very helpful if you're making your own criteria. But if you're using somebody else's tests, see if you can find some information on predictive validity. Concurrent validity is like predictive validity, except instead of happening in the future, it's happening at the same time. So one of the things that you can use this with if you're doing if you're using one of your own measures, is that if it's supposed to predict something else that you have a measure of, right, that you can get another measure of, you can use the two of those, measure them at the same time, and indicate that your measure that you made is actually a good measure, actually a valid measure due to concurrent validity. So if you needed a measure of picture intelligence, right? Let's say that your study had to do with people's ability to understand visual language. So you make up a study of picture intelligence. And you know from your studies of intelligence and your background readings of intelligence, that intelligence is often generalized. That people who are intelligent in one area are often intelligent in another area. Well, then you might say, well, general IQ should be related to picture intelligence. So I'm also going to give them a subset of an IQ test during the experiment. And then I'm going to compare the two. And if people that are high in picture intelligence tend to be high on IQ scores, well, that's another way of telling you that you are actually measuring what you think you're supposed to be measuring, because you have that concurrent validity. Something that should be related to it that's measured at the same time actually is related to it. Conversion validity, our scores on the measure related to other measures of the same construct. This one is probably not going to be very useful in this in your projects, because if you have another measure of the construct, you are highly encouraged to use that other measure of the construct, right? So if you're looking at depression and somebody else has a depression inventory, like Beck's depression inventory, please do not do your own depression inventory. So if there's another measure of the same construct, try to use that other construct. This is more for people who are developing another measure, a new way of measuring things, to see if they have that convergent validity. And then the last one, discriminant validity. Again, you're probably not going to use this very much because of the time concerns that we mentioned before. But measures that are valid, they should not be related to measures that have nothing to do with their constructs. So measures of depression should have nothing to do with measures of intelligence. Measures of visual intelligence should have nothing to do with measures of height, right? So these things should be divergent. And again, you're not going to give your subjects a battery of tests, in order to figure out divergent validity, but discriminant validity. But it is one of the ones that I wanted to include, just so you can, if in the possibility it comes up, you can take a look at it. All right, reliability. That's the other ones that I wanted to take a look at. So reliability, this has to do with the consistency or the stability of your measure. So if you have a measure that you're using, what is its reliability? How consistent is it at measuring the construct that you are trying to measure? So all measures consist of two opponents. You got your true score and you got your measurement error, right? And the smaller the measurement error, the greater the reliability. So if you're using somebody else's measurements, if you're using somebody else's tests or surveys or indices, if you're borrowing from other scientists, as you are encouraged to do, one of the things that you're looking for is you're looking for measures of reliability. Usually they will include some measure of the reliability of the techniques that they developed. So typically they come with a reliability coefficient. Those coefficients range from 0 to 1, and you're looking for ones that are closer to 1. The higher your reliability coefficient, the more reliable that particular measure is. So types of reliability that you might come across in the literature when you're selecting, should I use this test, should I use this test? There's test-retest reliability, and that's where you measure the same individual at two different points in time. And if it's a stable trait, those two measures should be the same. So if your measure is reliable, and you measure somebody on their IQ on Monday, and then you measure them on their IQ on Friday, hopefully those two measures will be very, very close to each other, indicating high test-retest reliability. You correlate the score of time 1 with the score of time 2. You want a correlation close to 1. Closer to 1, the better it is. Internal consistency reliability. This is where you measure different responses only at one point in time. There's a couple of ways to do this, and you can actually do this in your own studies. So if you if you're developing your own measure, right? If you're developing your own survey, or you're developing your own questionnaire, that's going to measure a particular construct, one of the ways to test your own reliability and let the reader know that the test that you made or the survey that you made actually has quality to it, actually has characteristics of a good survey to it. One of the things you can do is show that it has internal consistency and reliability. So one measure of that is split half reliability, which would be straightforward to do. where you take your scores and you split them in half. And you take, for example, the first half of the survey, and you take a subject score, and then you compare it to the second half of the survey, and you take the subject score, and the two of them should match if your survey is reliable. You can also randomize that. There's different ways of doing it. But again, it's a nice, easy calculation to do, and it's a nice way of saying, oh, I've made this new survey, and just to convince you that it does actually, it is a quality survey, here is its split half reliability. Look how close to 1 it is. Cronbach's alpha, this one would be a little bit more complicated to do and would require statistical packages, but that's where you correlate each item with every other item, so you can see it can get rather complicated. Item total correlation is where you correlate each item with the total score, so you take that one item out, calculate the score, see if it's related to that. Interrater reliability, probably not going to use this for this particular project, but if you are doing something that has observations to it, if you are doing something, for example, in a corpus analysis where you're saying, oh, this is an example of this is an example of that, if you can get interrater reliability, which again, I'm not expecting in this class, that's where you measure how close together two raters are. So how much in agreement are two different raters? And the higher the agreement, the stronger your reliability, the better your criteria, the more reliable your measures. All right, so those are the different types of reliability and validity. And again, this applies to when you're developing your own measures. This applies to when you're deciding who else's measures to use, right? So these are the two things that you want to keep in mind when you're saying, all right, I'm trying to develop a criteria for determining between these two conditions. Or I have this survey that Johnson and Smith came up with. I got this survey that Melinda and Beauregard came up with. Which one should I use? I don't know, I can't use them both. Which one should I use? That's when you start thinking about reliability and validity data. So what do you have to consider and what do you have to actually justify and prove? So things to consider, number one, the validity of your measures. So think about, are your measures actually measuring the thing that you are intending them to measure? All right, so put a little bit of critical thinking into that. And sometimes, the validity of your measures might be a little bit of a stretch, right? Sometimes your measures are going to be linked to other things that are measured. That's fine, as long as they still are getting to that underlying construct. All right, things that you have to justify or prove. The validity of your measures. You do not need to justify those. You do not need to prove those. So I've had some discussions with students where they're like, well, I don't know if this is measuring what I wanted to measure, or couldn't there be, this exception, or couldn't there be this exception, or maybe somebody only scored high because they were faking the results, or maybe they were doing this, maybe they were doing that. It's great to consider those, right? It's great to consider, is your measure actually measuring what you think it is? But do you have to justify that or prove that? And the answer is no. It would be nice if you could, right? But the answer is that you don't have to. So when you find, or when you come up with criteria, again, do your best to make sure, or to try to measure the concept that you're measuring. But if you don't think it's going to convince everybody, don't worry about it. If it's logical, that's what you're looking for. If it makes sense in terms of the research in the area, that's what you're looking for. But if you can't actually point to data or a number to say this thing is amazing, don't worry about that, because you do not have to justify your validity. And then other things, you want to consider the reliability of your measures, but again, you do not have to justify or prove that, right? Just oftentimes it's just to the best of your ability. We think this is, the best way to measure this. Nobody else has come up with this concept before. Here's our instrument, here's our survey. We think this is the way to do it. We think it's got validity. We think it's got reliability. Again, you don't have to do your reliability, but it would be nice if you could actually, in your reports, point to some measure of reliability. And we can talk about, when the time comes, that kind of split half reliability is oftentimes an easy way to measure.
So for now, we're supposed to consider this for design, but once we actually get results, what if we actually find out that we have failed to have any validity or reliability?
You mean once you do your results, if you do your split half reliability and it's horrible?
Yes.
Then that will be brought up in your discussion. So the thing to remember about reliability, number one, okay, so things to consider about validity. Validity is much more difficult to measure, right? So that kind of predictive validity, forget about it, right? You can get predictive validity next semester, right? So we'll do the research this semester, and if it predicts your subject's performance next semester, then that would be predictive validity. So we're not even going to have identifiers on our data, so that's not even possible. So measures of validity are difficult. Measures of reliability are a little bit more straightforward, especially that split half one, right? So you could take half of your measures and then take the other half of your measures and see if it matches up for each individual subject. If you find out that your reliability is low, that doesn't invalidate your results. What that does is it actually makes real results more difficult to find. So low reliability is kind of like an out of focus picture. It's still a picture of what you're looking at, but it's just really hard to find the details. It's hard to find the little effects, right? So if somebody said, is there a squirrel in this picture? And you're looking at a sharp, focused, AKA highly reliable picture. If there's a squirrel there, you could say, yep, there's a squirrel. If on the other hand, your reliability is low, it's kind of like your picture's out of focus. So even if there's a squirrel there, you won't find the squirrel. Now, if you find significant results, and if you find out that your reliability is awesome, then that's an indication that your results are your results, right? If you found significant results, great. If you found non-significant results, great. If your reliability is low and you find significant results, that's actually fine, because what it means is that that squirrel was so big that even when your picture was out of focus, you could still see it. So that's not going to be an issue. The time that reliability comes into it is when you don't find your results, because that means that either there was no squirrel in the picture or there was a squirrel, but your picture is too blurry. So even if at the end of your project, if you get null results and you do a reliability test and you find out that your measure was unreliable, then you have something for your discussion section, right? Then you have something to say, well, we didn't find any results. Part of that might be due to the reliability of our measure. This is what, the split test reliability indicated, compared to other measures, or compared to different scales. It was in the low reliability area. So even though these theories predicted we should find, results, as it turns out, we didn't, maybe due to the reliability of our measure. So you would address it in the discussion section. That being said, this is a good time to mention that one of the things, this is a little bit further along, but I will mention this a couple of times. When we finally get to our results, your results, we're basically going to boil it down to two things. Either you found something or you didn't find anything, right? Those are the two types of results you're going to get. Either you found differences or you found things that are the same. When you find differences, those are the ones that are very straightforward to interpret, right? If you found a difference, chances are there are a difference. What does the difference say? Here's your conclusions. When you don't find anything, when you find no differences, there's always two possibilities. One, there's no difference, right? You have actually found no difference between the two. The other is that you didn't have enough subjects, or your measures weren't sensitive, or maybe they weren't reliable enough. Regardless, though, I will have you speculate on what those no differences mean. So it's completely fine to say we found no differences. This might be due to low subject counts, but there will be that part that if this is actually true, that there are no differences, this is what it means. Because I oftentimes find, especially with advanced labs, students will find no differences, And that's where their thinking ends. They're like, well, we didn't find any differences, so we can't say anything. It's like, no, that's not true. You can say a lot of stuff. You just kind of had your get out of jail free card and said, well, no, P's not less than 0.05, so I'm not going to, tell what the implications are. So just bear that in mind. Regardless of what your results show, you have a story to tell. So I know from doing my own research, now probably everybody here knows what they want to find, right? And I know when I'm going into my own research, oftentimes, especially if it's a string of projects, I'll be sitting there just kind of praying, please go this direction, because that explanation is super simple. If you go in this direction, oh my goodness, I'm going to have to do a lot more work, right? So we always have that result that we're hoping for. But that's why you do the research, and whatever result you get, there's a story to tell. So if you find a difference, there's a story there. If you find no difference, there's a story there, and you'll still be able to communicate it. So whether or not your measures or results are fantastic in the direction that you wanted them to be, we're going to write them up for all that they're worth either way. All right, any other questions? Mm-hmm.
So what if you do have justification that like the measures you're using are have validity or reliability? Like where would you put that, like a citation?
That you would typically put in your method section, I believe. I need to look that up though. But typically, if you're using something that has high reliability and it's already been measured, you'll just mention that in your method section. I think if you yourself do it, like if you run a split test reliability, that would end up in your results section. But I need to just double check that. And then again, if you're making your own measures, as much as possible, try to incorporate things that point towards those measures, but you are not going to be able to have that level of certainty that people who are using other people's measures will. And then the last thing that I'll mention about this when you're thinking about your measures, as much as you can, farm your measures out to other people. And it doesn't matter if they're published in a scientific journal. It doesn't matter if they're experts somewhere else. As long as you can say this is their work and this is what they said is important, or this is their ordering of the criteria, then what it does is it takes out any criticism that you might have a personal bias for how you're doing the research. So for example, this is one of the projects in here. So I'm just going to use this as an example. So one of the projects here has to do with media bias, right? Has to do with biases in the media. And in order to do that study, different publications and different articles need to be ranked in terms of their bias. And you can imagine that that is something that is very subjective. That is something that is very, can vary a lot and people can object with. So the last thing you would want to do as a researcher there is to say, this is what I think the rank of bias is, right? I think CNN is over here. I think Fox News is over here. This is what I think it is. Because then any results can be easily dismissed or easily criticized by just saying, well, that's just because of your own bias. You ranked those media in terms of what you wanted to find, and then lo and behold, you found it, so that's a biased result. Much, much better if you can find something that has either been professionally made by somebody who is in the field, and then cite that and use them as your criteria. So rather than saying this is what I think the bias is, it's way better to say, well, this is a study that was done by, where'd she go? Done by Vitessa Ortero, and this is the rankings of the media bias. This is the ranking I'm going to use. Because if then people say, well, I'm going to criticize your rankings, you can say, well, go check out the article. If you want more details, go check out the article. But basically, it unloads your biases and allows you to be kind of more objective, to say, all right, I'm going to find what I'm going to find because I'm going to use this person's measure of bias. So do that, especially if you have anything that requires selection from a larger pool. All right, so for example, if you need to select stimuli, or if you need to select blogs, for content, or if you need to select, any sort of data that you are getting from, different sources, you can either find the top recognized, sources of data. So if you're looking for age demographics in the United States, you can just look for Google age demographics in the United States, and pretty much the first 3 results are going to be like the U.S. Bureau of, Census Bureau, and then the one below that will be the World Health Organization, ones. And it's use those sources if you can. If you don't have reputable sources like that, once again, you have a selection that you could use. Oftentimes, what I would do is I'll just let Google select for me. And I will just say, if I need, a selection, I did this myself, I needed a selection of the top 100 iconic comic book covers of all time, because I wanted to show that one of my theories would actually work to explain the visual language used in the most iconic covers of all time. If I came up with that choice, if I said, I think it's Amazing Spider-Man number 50, and I think it's this, and I think it's that, any reviewer could say, well, that's just your opinion. You chose those covers because those were the ones that fit with your theory. No wonder you found the results that you did. So what we did is we just Googled top 100 iconic, comic book covers of all time. And we found, I believe it was 15 lists. And then we just took everybody else's opinions, cross-referenced them, and said, the ones that appear on the most lists, those are going to be the ones that we analyzed. And that's how we ended up with our sample. We didn't choose them. Right? It was somebody chose them, right? It was a kind of like a pooled survey, but look for those types of techniques as well. So if you're wondering, well, how can I justify this choice, or I need to choose from among the stimuli, how can I justify it? If you can farm that out to some other source, either expert level organizations or knowledge, or, do it crowdfunded way where you just put it on Google and see what the first 2 pages say, see what the first page says, and use those. That is a completely valid way to kind of remove your own selection bias. All right, a lot of information going around. Let's actually get together right now so we can work this out. So we're going to do the same thing we did last time. We're going to split up into groups. All right, so that appears to be time for today's class. So if there's any final issues or anything, I do have my office hours ready to go until 5 today. But do continue to work on your introduction draft and start continuing to think about your method section. We're going to get to the point now where final decisions will need to be made. So again, think about the validity of your measures, especially if you're making it on your own. But do not panic if you have no more justification for your measures, then I think this is going to work. If you can go beyond that, absolutely do that. But it's okay to just have information that points towards the validity of the measure that you're using, such as backgrounds, ideas, and theories. All right, so that is it for today.